Lab1 draft. So for our introduction, ordinary objects can acquire an excess of negative charge or net positive charge if they are rubbed, pulled apart, or come into contact with other objects. And the primary interaction that happens between objects are the removal of single electrons. So in this experiment, we were studying the different interactions between charge U-tapes and the objects that came into contact with them. And this would cause an excess or deficiency of electrons, which would cause negative or positive charge respectively. And for the principles we wanted to study with these were primarily electric forces, point charge interactions, and later on Newton's second law. And so for the overall goal of this experiment was to determine the actual amount of excess charge on a tape in an order of magnitude if it interacted with each other. So for our materials, we had clear or invisible tape, which is around 20 centimeters long, and then a ruler, a flat surface, and two thick hooks. So before the main experiment, we wanted to see the different interactions between the charge U-tapes and what specific effects they had on each other. So for pictures 1 and 2, you can see the attraction of a charge U-tape with my hand, and then also the repelling of two charge U-tapes. From these pictures, you can see that obviously my hand and the charge U-tape had opposite charges, while the two U-tapes obviously had the same charge. And then further on the third picture, we can see that there was no visible interaction between a charge U-tape and a neutral book. So then by negatively charging a plastic pen and drawing it towards the charged U-tape, we could see that the U-tape was actually attracted to it, which meant that the U-tape was positively charged, and this resulted in an electron deficiency. Now for the main experiment. For this experiment, we dealt with two charged U-tapes. One was suspended over the other and caused a repelling force. So for this experiment, we labeled the two charged U-tapes as 2 point charges, which were A and B. And these were separated by a suspended distance, which was measured to be around 2.4 centimeters. And from this, we can see that U-tape or tape B was repelled, and two main forces were primarily acting upon it, which was the electric field force from point A, and as well as the gravitational force, which could be found by multiplying the mass times the gravity. Now, in order to perform our calculations to find the actual charge, we could use the electric field of a point charge formula. And so substituting the actual electric field force for mg, we could see that multiplying QB times this formula would give us the actual constants needed to find the charge of point B. And so plugging in our gravitational constant, our mass, which was 0.2 grams, and then as well as separation distance in meters, which is 0.024, as well as Coulomb's constant, and we could then multiply the mass and the gravity out and divide the Coulomb's constant to get the charge of point B, which is around 1.12 times 10 to the negative 8 coulombs. And so dividing this number out by the actual charge of a single electron, which is 1.6 times 10 to the negative 19 coulombs, we could get 7 times 10 to the 10 electrons for the total amount of deficient electrons since the charge was found to be positive. Now, in order to find the actual ratio, we had to figure out the actual total number of atoms on the sticky surface of the tape. And you could do this by dividing the surface area by the area of atom, which you would get 4 times 10 to the 17th atoms. And then finding the ratio of deficient electrons to total atoms would get you around 1.75 times 10 to the negative 7. For the coding portion, our main assumptions were that we wanted to treat the charge tape as a point charge, just like the diagram before, and we wanted to ignore air resistance and ensure that there is even distribution of charge along the tape. And so for the coding, you can see that different vectors and different particles were assigned to each other to find the charge, which is found by square rooting the actual magnitude of electrical force and then also dividing by Coulomb's constant. We can see that the approximate charge we got was equal to the charge we found before. Some questions to consider. So if electrons have a positive charge and protons had a negative charge, this would ensure that opposite interactions would occur from what we can see before. Since electrons transfer between objects, an excess or deficiency of electrons would actually cause a positive or would cause an excess of positive or a deficient of a negative. It's important to handle the charged tapes as little as possible because the transfer of charge across different surfaces can affect the tapes, and some areas can consist of weaker or stronger charge depending on different objects interacting with them and causing a transfer of electrons.